All right. The anti-derivative, we have nothing really new to do. My plan today is to put some up here, kind of like a little practice gateway. Here's kind of what it would look like. Here's what the different ones, and give you a chance to work them, and then we'll check them, and we'll talk over them, kind of go through that, and give you some work time too, and maybe do a little of that tomorrow as well. The integration by parts. So like I said yesterday, we got the kind of three techniques, I guess. Really, the first technique would be the absence of technique, right? The one where you just have a basic antiderivative, just follow the rules. Maybe you have to kick out of 1/2 or something like that, but where you just do the antiderivative of the different pieces or whatever. So there's not really a U substitution to do. It's not really integration by parts. It's just straight antiderivative. So that'd be one technique, I guess you'd say. And then the second would be U substitution, which is going to be the majority of the time probably. And then your integration by parts, okay? So identifying those is really the key. I think the integration by parts, there's probably not going to be more than a couple of those. I always see people, and it never fails, no matter how many times I say it, that we get to the gateway test, and somebody will be doing U's and DV's like on 7 problems. It's just not going to happen, right? There's not going to be that many where you have to do the integration by parts technique, okay? It's not a matter of you can just choose which technique you want to use. You're either going to do U substitution, you're going to do integration by parts, or it's going to be a straight antiderivative. Now, it's possible that within a problem, as you saw in some of these, and we can look at a few, that you end up doing both in the same problem. That would be a hard one, right? That's probably not going to happen very often on the gateway test, but it could happen. But it wouldn't happen more than probably one time at all, okay? But it could. So let's look at one of those. What was the one we were just talking about, 31 or 18? Or 31 was one. So let's look at 31. So 31 says the integral of x cubed, is that the one? And then e to the x squared dx, okay? So again, your thought process on this one would be, okay, there's an inside. See, here's why you wouldn't probably think of integration by parts right away on this one. I mean, it kind of looks like an integration by parts. We had one yesterday, it was like x and e to the x, and that was integration by parts. But this one has that x squared on the inside, so that makes you think of maybe letting u be that. And then the du would be 2x dx. Now, there's an x dx sitting there, but there's extra x's, right? There's the x squared sitting there, but we figured out that if you have extra x's, we can usually deal with that somehow, right? So that at least might get you started on this one. So that is, as it turns out, the way you want to go. Okay, you want to let u equal the x squared, and the du would be the 2x dx, like that. All right, now there's no 2 up in here anywhere, so that's probably going to want to go over there. Now, when we do integration by parts, so remember, we don't ever do that. We don't move that number around over there when we're doing the other technique, when we're doing integration by parts. But here, we're going to move that around. So when we look at this, okay, when we look at this problem then, we can see that that's just going to be e to the u, okay, and we can see the x and the dx. So now our x cubed can be thought of as an x and an x squared, like that. We can think of our x cubed as an x and an x squared. This is all multiplied anyway. All this is multiplied, so we can split it apart like that. So our x and our dx is going to come out and be a 1/2 and a du, like that. And then what's left? We still have this x squared, so we take care of that here. And now we got this x squared, but that's what? That's u. So we can take the x squared out, and we can just replace it with a u. Well, now that is a good integration by parts problem. That's actually the very first integration by parts problem we did yesterday. We did that one. Well, I don't know it was the very first one, but I think it was actually the first integration by parts problem we did. Now, the problem becomes you already have u in there, so you might want to use something else. So a lot of times we use w. So if the formula is uv minus v du, now it'd be wv minus v dw, like that, right? All right, so W would equal, now we got Liate, so we got an algebra and an exponential. Well, algebra would come before exponential, so we'll let W equal U, and we'll let the dV be the rest, which would be the e to the u and the d. Okay, dW would be du, and here the v would be what? e to the u. And what happens to that du, Braylon? It just disappears, right? It disappears. That du just goes away because we're just doing the reverse. We're just doing the antiderivative of this. So we just do the antiderivative of that, and we get that right there. Okay, so now what do we got? We got WB, so this times this. So that's u e to the u minus the integral of v dw. V dw, so that'd be e to the u du. And that's easy. That's just e to the u. So we get u e to the u minus e to the u. Now we got to be a little careful. When these start getting messy, we got to be a little careful. For example, this 1/2 kind of got lost there. So all of a sudden, if you forget about that 1/2, you might lose that. That 1/2 needs to go on top of all of this. And then also we got to go back to our x squared there. So we end up with 1/2, that'd be x squared, e to the x squared, and then minus e to the x squared. Oops, 1/2. Put a 1/2 on that, or put a 1/2 and then all this in parentheses is fine too. E to the x squared plus c. So it'd be all that there. That would be a hard one. That would be a hard one for sure. Okay, having to do both of those things in one problem. All right, what was another one on the integration by parts while we're on it?
67
So was that an integration? That's not an integration by parts. Which is fine. I mean, we can certainly do it. We can certainly do it, but it's just not an integration by parts. Anybody have another one out of the book? 17. What was that one? X and ln x. Like that.
And then it's like from 1 to e. Yeah.
And it's from 1 to e. Now, yeah, the other part of that, was that the one that talked about midpoint sum and
there's like big M.
Yeah. Ignore that part. So the first part of direction says evaluate using integration by parts, and then it said something about comparing with midpoint. We're going to learn that in later now in chapter 5. Okay, after the gateway test, that's the next thing we're going to be doing. And this is chapter 8, right? So they assume we've already learned that. So that part we have to ignore. Yeah, that M20 part we have to ignore. But the rest of it we need to be able to do, right? So this again, mixture of function factors. You notice the integration by parts ones just look simpler. I mean, because they don't have stuff in them. They don't have stuff on the inside. They don't have powers usually. They're just kind of like this, right? I mean, they're an algebra with a trig, or they're a trig with an exponential, or an exponential with a log, or and they're just and they're kind of a product rule. It's kind of like two things multiplied together, but a lot of things are multiplied together. But it just doesn't have any inside piece or any fraction where we can do the bottom or whatever, right? And that's what kind of identifies them as an integration by parts. They're just nothing you could pick as a u substitution. So Liate would tell us that we're going to let u be the ln x, the log, and the dv is going to be the rest of it that's left over. So that's going to be that right there. Okay, and so the du is going to be 1 over x dx, and the v is going to be 1/2 x squared. Okay, so we just do the antiderivative of the x squared. So u times v, so that'd be 1/2 x squared times ln x, or whichever order, doesn't matter which way we multiply those, minus the integral of, now here's where we want to be careful here. Whenever I see this, when I have v times du and there's stuff there, I usually go over to the side and work that out. So I got 1 over x times 1/2 x squared. So I would come over here and work this out. Now you can write it all in there, but that usually, for whatever reason, and I had that question already from some people this morning, for whatever reason, as soon as you put the 1 over x and the 1/2 x squared, if you put them inside here, we just get all confused. I mean, we just look at that and we don't know what to do. So I almost think it's better to not put it in there until you're ready, until you know what that's going to look like. So to me, you're multiplying this together. This x is going to cancel one of those. And so now it's easier. Now it's 1/2 x. Now I can just take that 1/2 and put it down here, and I can put the x in there and the dx, and it's just going to be that. Okay, so when you get these x's with powers and a negative power, you just add the powers. Just add the power. So it's a -1 plus 2, do it that way, whatever. But it's usually going to simplify. I'm not gonna worry about the 1 and the e till I get done at the very end, okay? So now, which is coming up right now, so I'm gonna have 1/2 x squared ln x. And then I'm gonna have minus, now this will go up to a 2, divide by 2, so that would be 1/4 x squared. And normally I'd put on a plus c, but now I go ahead and I put on the 1 and the e, right? And the reason they had you do this M20, what that is a midpoint sum. It's a way of approximating, right? When we were doing definite integrals the other day, I said we can do geometry, we can do fundamental theorem, which is this, antiderivative, or we can do approximation. Well, that's an approximation technique. So this one, they were going to have to get. So you put the e in there, so it's going to be really ugly looking, but just 1/2 e squared. What's ln e? Ln e is just 1, so we can forget that. Minus 1/4 e squared. So I put e in, and this would be minus, and now I'm going to put a 1 in. And so I get 1/2, 1 squared, but what's ln 1? That's 0, so that's going to wipe all that out. And so this is just going to be negative 1/4 times 1. So that actually just becomes plus 1/4. And then that'd be it.
Okay. Wouldn't it be 1/4 e squared?
Oh yeah, these I could put together, can't I? Yeah, I could actually simplify that. 2/4 e squared minus 1/4. So that'd be 1/4 e squared, and then this is plus 1/4. Right. So yeah, I would want you to do that. That's another fairly tough one, just because when I say tough, it's because there's a lot of little places to mess up something. On the gateway test, it's all or nothing. You miss one, and so, that's makes it becomes just a little tougher when you have to do this, when you have to do 1 to e, because that just adds a little more to it. Does that make sense? Right? Yeah.
You want us to simplify like how much we did last time?
Yeah, I think so. I mean, to be honest though, there just isn't much simplifying to do on antiderivatives generally. I mean, here when you do have a definite integral and you're getting a number answer, yeah, you should simplify that. And what Dallin said, we should have simplified that at that 1/2 e squared minus 1. I should have seen that. I did. But yeah, that. But a lot of times there isn't much. You do your u substitution, get your antiderivative just kind of there. They're really not like derivative where we had a lot of simplifying to do and canceling maybe. For antiderivatives, there isn't that much, Jim. Okay, yeah, James.
Could you do 19?
What's that one?
It's the integral of x squared arctan x dx.
X squared arctan.
What's the integral from -1 to square root of 2 over 2?
Okay. So, like that. It's x squared arctan. So we got an algebra and an inverse trig. So we look at this, and again, we know this is integration by parts because it's in chapter 8. So we know it's going to be, and the directions say it. But if this was a gateway test, how would you know? Well, again, because there's nothing to let u equal, right? I mean, you can let u equal arctan. What's the du? What's the derivative? 1 over 1 plus x squared. Is that sitting there? It's not sitting there, right? If you had, I think we did one like this actually. If you had this integral, if you had arctan over 1 plus x squared dx, and that's a great u substitution problem. You let u be the arctan, the du is 1 over x squared, 1 over 1 plus x squared dx, which is sitting right there. Boom, the whole thing becomes u du. It's a great u substitution problem. Okay, but this one isn't. This one isn't. I mean, there's just nothing to let u equal. That's sitting there. You let u equal x squared. The du is 2x dx, and there's this arctan sitting there. We don't know what to do. So this one it's a mixture of two different function families. It's got to be an integration by parts. Okay, so we got Liate, so inverse trig. The I would come before the A, the algebra. So we're going to let u equal arctan. Okay, and we're going to let the dv be the rest. So that's going to be the x squared dx. And so you notice we don't do anything with the dv. You notice that, right? When we do our integration by parts, right? What do? We do u times v. We multiply these two, and then minus the integral of this times this, right? We don't do anything with that, which is okay. That's why that can be kind of a complicated thing sometimes, and it's not going to affect us. Anyway, du equals 1 over 1 plus x squared. dx, and the v is going to be 1/3 x cubed. Okay, like so. So we get u times v, so all that, 1/3, oops, x, yeah, cubed. So 1/3 x cubed arctan minus the integral of this times this. So now I look at that and I say, okay, that's kind of messy, but I can't really simplify anything. So the 1/3 could go out here. The x cubed could go on top. That's 1 plus x squared, like that, dx. Okay, this does kind of look like one we've had before. So this, what number was this? 19, yeah. And so how are we going to do that integral in? Use substitution. Now again, one at the most, where you'll have to do both parts. Like you start with a u. Now this is actually the integration by parts in u substitution. We saw earlier we did a u substitution, and then we had to do an integration by parts. So we've seen both ways, right? Could happen. It's not going to happen more than once, right? Generally, what's going to happen? You do u substitution, you get an answer, or you do integration by parts, you get an answer. Okay. Generally, that's what's going to happen here. Okay, so on this one, we're going to do a u substitution. So we're going to let u, now on this one, we don't really need to change our lettering because we're back to x's, so we can go ahead and use u again. We're kind of done with that one. And we're going to let u be what? The 1 plus x squared. Okay, the du is going to be 2x dx. There's not really a 2 up in there anywhere that we can, so we're going to move that over there. Okay, and so now, what does this integral look like? Now I'm going to leave off, and I'm not going to leave off the 1/3. I'm going to bring the 1/3 along, but the negative, I'm going to remember I got this negative here, so I got to distribute that. So staying neat with your work's kind of important. So when I sub this out, this is going to be u down here. The x squared, I'm going to think is x, the x cubed, I'm going to think is x and x squared. Okay, and we've had a few of these now already. So the x dx, that's right there. So that's going to be a 1/2. Now I said I was going to bring my 1/3 along just so I don't forget about it. Okay, so I bring my 1/3 along. I got my 1/2. Here's my du out here. And then what else is left? I've taken care of that. That was u. I've taken care of the x dx. What I got left? An x squared. So what's that? X squared is u minus 1. So I put a u minus 1 right there. Now I can split that apart. Now this is a 1/6 out here. And now I got u over u, which is 1. And I got 1 over u, which is going to be ln. Okay? All right, so what do I got here? I got 1/6 u. So the antiderivative of 1 is u. And I got a 1/6 ln u. Right? And what was u? U was 1 plus x squared. Okay, so this is fun one. All right, so let's start way back here at the left. Let's write it all out. So we got 1/3 x cubed arctan minus. Now I already took care of this 1/3, but now I got to distribute this minus. So it's going to be minus a 1/6 u. So that was 1/6 the 1 plus x squared, and then a minus. It's going to be a. Is that going to be a plus now? Because I got to distribute this minus. So it's going to be a minus 1/6, and it's going to be a minus a negative 1/6. So it's going to be a plus 1/6 ln, and then that's 1 plus x squared. I don't need the bars because it's, I think we got it. Okay, so yeah, that's one of those, if you get that, great job. If you then that way you can miss 1 or 2 silly ones, stupid errors, or some which you're probably going to do, right? You're going to do that at least one time. But this would be a hard one. Now, what have we not done yet? I just realized. The root 2 over 2 and the negative 1, right? It's a definite integral, right? This has got it all, right? This one's got everything. I mean, this has got the integration by parts, got u substitution, and a definite integral. Now, luckily, root 2 over 2 is nice for our tangent, but it's going to be a mess with all this stuff, right? So I'm not going to worry about it right now. Although, what is arctan of root 2 over 2? Is that even a nice number? That's not even a nice number. The angle whose tangent is root 2 over 2. Sine or cosine, or sine or cosine would be pi 4s. So that's not even a nice number. So yeah, that thing's gonna be messy. Now arctan -1, that'd be negative pi 4s, right? That'd be down here. Tangent -1, that'd be negative pi 4s. But otherwise, those are some ugly numbers. So we won't have it like that. We'll do some review here. You'll see kind of something. What we'll do every day with this. But this is good. I mean, we gotta go through some of these. All right, what was the one you had to reach? 67?
Yeah.
What was, read me that one. While he's finding that, I'm not going to put this on the gateway test either, but there is some integration by parts one where you have to do it twice. Like you do integration by parts, and then the integral you end up with needs to do integration by parts again. I mean, just like we did a U substitution, then need integration by parts, that can happen too. I'm not going to put that on the course, but it wouldn't be any harder than the ones we do in there. You got it?
It's integral of e to the x squared root 1 minus e to the x.
E to the x. E to the x, and then square root. Okay, so e to the x, and then the square root of, what was it, 1 minus?
1 minus e to the x.
E to the x, so that'd be to the 1/2. Just like that. Is it a definite integral? Or?
Yes.
Okay. All right, so what do we want to let u equal there? The inside, right? We let u be the inside, so now the du would be negative e to the x dx, which is good because that's setting right there. So, and then maybe move this negative over here, and you get e to the x dx. And so now we're looking at, okay, e to the x dx, that would be this. So that's going to be negative and a du. And then we got this, which is u to the 1/2. So now we raise that up, want to be 3/2, divide by 3/2, it'd be negative 2/3 u to the 3/2 plus c, which would be negative 2/3, 1 minus e to the x to the 3/2 plus c. Just like that.
So you just have to recognize that there's only one type of function.
Yeah, you mean not to do integration by parts?
Yeah.
Yeah, I guess I think of it backwards, or the other way. I always think of U substitution first. To me, integration by parts is last resort. Last resort, right? I'm going to look at it as U substitution. So when I see one like this, right away I see an inside, right? That's what I see. I see something on the inside. So I think that could be a good u. And then I think the next step is, what's the du, right? So I think 1 minus e to the x is my u. The du would be e to the x negative, but e to the x dx. Oh, and that's sitting right there. And then integration by parts doesn't even enter my mind because I'm thinking u substitution. Oh yeah, it looks like a good one. And then I go. You know what I mean? And then the other thing is, what would be my options? Because if I let, because you're right, you have an exponential and an exponential, and then Leonte doesn't do any good, right? I mean, so then you say they're both exponentials, and you say, or you could say this is algebra because of this. But if you let u equal that, I mean, just think of that. If you had to let u equal 1 minus e to the x to the 1/2, and you let the dv be the e to the x, think about this. What would the du look like? Wouldn't it be a god-awful mess? Think about that. If you let that be the u, the du, you'd have to bring down to 1/2. You'd have 1 minus e to the x to the negative 1/2. Then you'd have to kick out a negative e to the x, right? That would be your du. And in your integration by parts, you're going to do v du, and so that your v is going to be e to the x. I mean, that would be awful. And usually integration by parts doesn't get that way. You know, that'd be another reason, I would think. If integration by parts was entering your head, and it was just becoming this awful, monstrous looking thing, it's possible that wasn't the right option. Does that make sense? So but that's my thought process, is integration by parts is gonna be the last thing I think of. I'm gonna look for a U substitution right away, because 6 out of the 10 are gonna be that problem. It's just, here's why, the LH packet doesn't have any integration by parts, so, but that's kind of unfair, that's a hint that you're not gonna get on the gateway test. So I'm trying to give you a little bit of a hint that most of them are gonna be U substitution on the gateway test, not integration by parts. Yeah, this one's just a good U substitution. So, now, on our final, on the AP test, I will tell you, integration by parts is not on there, right? It's something that I've chosen to do. It's a Calc 2 thing. It'd be the next thing to do in Calc 2. I think, I just think it's important we do enough and a little bit more of these so you can see some other things leading into calculus. But it won't be on the AP test. Matter of fact, while I'm thinking of that, I pulled up a couple of AP tests here, or previous year's AP test. This is 2017, so just for some quick practice here, let me show you. So just in your notes here, or somewhere, let's do a couple of problems here. Oops, I don't know what it's called. Okay, let's do, do that problem right there. This is from this is from last year's, this is the international version of the test, but this is from last year's, no calculator, multiple choice, question number 2. Now the nice thing about multiple choice is you kind of get a hint as to what's happening there. So you can almost just look at the answers and almost do the derivative and think about how that would work, but I don't know if that's saved any time. What do you got? Now, B and C on here. Okay, so let's pretend it wasn't multiple choice, and we had to do this one. Okay, what would you do? Take out a 3? Take out a 3? Now, what would be the advantage of taking out a 3? You could bring a 1/3 out in front, right? So if you took out a 3, you would have this, and then, yes, then that's the same as a 1/3 being out in front. Okay, because when you multiply two fractions, just multiply across, and this would be that. And then isn't this just an ln? It's just shifted 4 to the left. So that'd be 1/3 ln x plus 4 plus c, which is b, right? Choice B. So I agree. I think that's a good way to do it. Now, the other way you could do it is you could say, well, that's just an ln. That's just ln 3x plus 12 with a what kicked out. Since there's a 3 multiplied by the x, there'd be a 1/3 kicked out. Okay, but now, so I was thinking some people might think of that. But I like the fact that you take out the 3, and you would probably do it because you notice all these had x plus 4 inside. So you can tell they all had taken out a 3. But I could see somebody doing this, and I would actually accept that answer on the gateway test. If you did this, you said, well, this is just an ln, 3x plus 12, since it's only a constant there, I can just kick out the 1/3. If it was an x squared or something, I couldn't do this, right? If this was a 3x squared plus 12, we could never do this, what we just did, right? It wouldn't be an ln. Okay, only because it's x to the first power is it an ln. Very important to understand it. Okay, but here's why. Because this is 1/3 ln, and then if you take out the 3 now, and you get x plus 4, now you get into that ln rule of ln of a multiplication. You can add the two ln's together. So this would be equal to 1/3 ln 3 plus 1/3 ln x plus 4 plus c. Well, what happens to this 1/3 ln 3? Just gets absorbed into the c, right? And so that's why it ends up being 1/3 ln x plus 4 plus c also. Okay, so let's, got another one here. Let's see, let's don't do that one. That's not really a gateway type problem. This one is number, no, I don't want to do that one either. I don't want to do that one either, not right now. Okay, that's average value. Let's go to, no, let's save that for now. All right, never mind, I'm just talking to myself, don't mind me. All right, so let's do this. Let's do some practice. Okay, so you might start on a clean sheet of paper somewhere in your notebook. So I got about 11 problems. We're not probably gonna have time to get through them all, but we'll, okay, so do this, write each of these down and leave yourself some space so you get them written down, because then I may move on a little bit, and if you haven't had time to finish them or whatever, we may do 4 or 5 or 6 of them and then come back and check them. So write these down, give yourself some space, and then work them. And if you want to check with each other a little bit, you can too, it's fine.
Is that 5 or 6?
There's going to be, I got like 11 of them. Oh, right here. Yeah, that's a -6. Thank you. Yeah, there's some stray marks on here. This is, yeah, that's a -6 right there. Has everybody got those written down? Those three. Can we check the first one real quick? Now I did these this morning, and these first few I hadn't drank any coffee yet, so I might there might be a negative off or something. So if I miss something, let me know. Okay, so it's a matter of, hey, you need to simplify that first. You need to distribute this through, right? You need to distribute that through first, and then you can do those anti-derivatives. So again, that would be the first technique, which is no technique really at all. It's just some algebra, some straight anti-derivative formulas. Of course, you got to kick out on 1/4 here when you got a 4 multiplied on the inside. You could do a U substitution, but you don't really need to. That 9 is just kind of like pulled to the outside, so it's just an arc sign recognition, and then your basic rules. Raise that up to a 6, divide by 6. Raise that up to a -2, divide by -2. Okay, how about the second one? Are we ready for that? Or wait on that one. Okay. All right, go ahead and keep working. It's fine. If everybody's got those written down, everybody's got them written down though, you said? Everybody's got all 3 written down? Okay, let me, I'll put the next 3 up just in case you get that far. But go ahead and just work on those first 3 fine. But if you get there, you can go to those. Now, again, opportunity to ask questions here too, so if you want to check with each other, it's fine. Or if you're stuck on one, come up and ask me too, right? I mean, if you're really wondering about something. Now, we'll go over them too here, but okay, here's what I got for number 2. So remember, it's no calculator, so if you get a value, so if I had picked different numbers and this would have came out to be cosine pi, then we'd want to put -1 for that, right? Or cosine pi 6, we'd want to put root 3 over 2, or whatever the case may be. So if it came out that way, we won't do it. But if it's just cosine 2, cosine 1, we don't know what those values are. So we just leave it in that case. Okay, now let's talk about this one a little bit. So when I look at this one, right away I'm thinking u substitution, I see the inside is square root of x. That's x to the 1/2. And then, so that's the inside, so I think of that for the u. And then I think of the du, and I think, okay, x to the 1/2, that'd be 1/2 x to the -1/2. Oh, x to the -1/2 is on the bottom as x to the 1/2, which is a square root on the bottom. Oh, great, there's a square root on the bottom. It's there, perfect. That is beautiful. That is u substitution at its finest. That's what I want to happen. So I pick u to be that inside x to the 1/2, and the du is setting right there. That's great. So that's the way we went. Now this 2 is kind of extra, so I multiply that over to the other side, and I get a 2 there like that, right? The 1/2, that goes to the bottom, so the 2's there. But the 1 over square root of x dx comes out. The 2 and the du goes in its place. It gets sine of u. Now, you can either do the red or the blue. You can change those u numbers like we were doing the other day. You just take your x numbers. These are x numbers. You put those into here. Square root of 4 is 2. Square root of 1 is 1. So change the x numbers to u numbers, or go back to your x's and use your x numbers. Doesn't matter. You get the same answer either way. Okay? All right. Let's look at number 3 here. That's an integration by parts. That's an integration by parts. I would look at that one, and again, I'm thinking u substitution, so I'd look on the inside, 9x plus 9. Oh, well, that's just going to be a du, just going to be a 9, which I can kick out of 1 9, so that's not really going to be helpful. I have an extra x there, so you might say, well, okay, extra x, I could just solve for x, but then I got that cosine there. See, I'd have cosine of u, and then I'd have another u's out here. So I'd still have u's and a cosine of u's. That doesn't help me. That's the same as having x's and cosine of x's. I wouldn't be getting anywhere if I tried to do a u substitution. So that's why, so the thought process is try to do u substitution, and hopefully it works out as a nice u substitution. But otherwise, that's when I start thinking, okay, maybe my last resort, maybe, yeah, this is a mixture of function families. It's an algebra with a trig, and so the inside didn't really seem to help me. Now, if this would have been a 9x squared, it'd have been a different story. If this had been a 9x squared, then my du would have been 18x. The 9 would have went away. I'd had 18x, and then I just said, oh yeah, there's my x. And then it'd been a great u substitution. So if this would have been 9x squared in here, it'd have been a wonderful u substitution because it would have taken care of that x on the outside. But it's not. So it becomes an integration by parts. And so algebra comes before trig, A comes before T and Liate. So I'm going to do that. Remember, we never divide this 7 over here. We leave it right there. And we got to kick out a 1/9 right here when we do our antiderivative of cosine. We got to kick out a 1/9 here. Okay? So u times v, 7 times 1/9 is 7/9 with an x and a sign. And then v du, the 1/9 and the 7 make 7/9. And just pull that outside, I got sine. Again, I'm going to do the antiderivative. I'm going to kick out a 1/9. I'm going to kick out a 1/9 here when I do the antiderivative. And the antiderivative sign is negative cosine, so that turns to a plus. 7/9, and then another 9 on the bottom is going to be 7 over 81. Okay? Questions about that one?
So it's the integration, don't divide the 7 over.
Right. On on integration by parts, we do not want to divide that 7 over. Why? Because we want to do u times v. So we want what u is. So we want to keep u alone. We want u equals u times v. So we want to keep those, right? Minus the integral of v du. So v, we want to know what v equals to plug that in. And then du, so we want to know what du equals, so we can plug that in, right? And so if we put this 1/7 over there, then we don't have du equals, we have 1/7 du equals. And see, on u substitution, though, it's usually the opposite. On u substitution, we're not wanting what du equals, we want to know what dx equals. We want to take 1 over square root of x dx. We want to take that out, so we want to know what 1 over square root of x dx equals. So this 2 is kind of in the way, so we move it over. Oh, okay, 1 over square root of x dx equals 2 du. So we take this out, and we put the 2 du in its place. Does that make sense? So that's the opposite. So in this one, our formula says v du, so we want to take v, and we want to times it by du. So we don't want that 7 over there. Okay, so yes, that is a difference. In those two. Okay? All right. So we said, okay, we did those. So is anybody ready to check any of these? Let's check number 4. Let's check number 4. Now I'll give you a little more work done. Okay? Here's number 4. Okay, so the first one is just a straight arc tangent with a 3 out in front, right? That 3 can just come out. Remember, because you can think of this as just 3 separate integrals, right? We can just separate this into 3 separate integrals. So in the first integral, pull out a 3, we got an arc tangent. This one, I'm going to think of that as 9x to the -3, so I raise it to a -2, divide by -2. And then on that cosine, I got to kick out a 1/8. Got to kick out a 1/8, so that makes 3/4. And anti-group cosine is sine, so the sine stays the same. The inside always stays the same, so the okay, so again, that's back to just kind of a basic, just using your anti-derivative rules there. Okay, all right. So I'm not gonna show the next ones yet, in case you're not ready, but I'll put up a few more here. So hopefully you got those. Everybody got those others copied down? 4, 5, and 6. Everybody? Okay. So here's 7, 8, and 9. If you're ready, want to look at those. Okay. Otherwise, keep working on the other ones. recording all this empty time, and now I just didn't record that. Okay, anyway, so here it is, and that's if you use the U numbers, or you can go back to your X's, you can go back to your 1 over U, plug your 1 in your E, and it's the same thing, 1/5. Okay, all right. Let's do one more. Let's look at one more answer here. So number 6. I want to look at that because that again is an integration by parts. So I threw an integration by parts here. Again, what would be your thought process? You might look at the inside. It's not really an inside. The 2x to the 5th plus 8. You can let u be that, but what good does that do you? And then your du is like an x to the 4th, and that's not there. You got your ln x. You can let u be that, but then the d is 1 over x dx, and that's not sitting there either. So there's no obvious u. There's no inside. There's no thing you can let the u equal that would give you a du. So the only other option you got is integration by parts. Okay, it's integration by parts. We can't just do these separately. We can't do this antiderivative and that antiderivative, not when they're multiplied. We can't do that. Well, we don't even know the antiderivative ln x, so it wouldn't work anyway. Okay, so we just have no real option here except integration by parts. So we got a log, we got an algebra, Liate, log would come first, so we let u be that, we let dv be that. Now, when you get your du here, 1 over x dx, you get your v here, which is the antiderivative, would be that. When you go to put it in, you got u times v, so that's fine. Make sure you got parentheses, but then I realized that I'm going to have the integral of v du. So I got v times du. Well, when I look at that, I can tell that's going to simplify. This 1 over x is going to like cancel some of those things. So I go over here to the side and I say, okay, I'm going to take 1 over x times this. So that x is going to cancel one of those x's and cancel that x when I distribute them. So that's going to be 1/3 x to the 5th plus 8. So I like to kind of come over here and do that to the side. If I would have put this into my integral, it just gets confusing. People look at that and they don't know what to do for sure. Okay, so I like to go off to the side, do my simplifying, and then bring it back into the integral there. Okay, now I just do a simple power rule. Raise it up 6, divide by 6, be 1/18, and then the antiderivative 8 is 8x. The minus has to distribute through here. So notice how I distributed that minus through. Okay, so similar to what the gateway test is going to be like, that's 6 of them so far, right? How are you doing? Have you only missed 2? Have you missed more than 2? What do you think, right? I mean, you don't have to tell me, but you know what I mean. So think a couple days, right? We want to be able to go through here. So how much more practice do we need? So we're going to get some more of this tomorrow in class. I'm going to give you some websites here. Okay, let's write down, first of all, let's write down a few more here. 10 and 11, write down these 2 problems here. Okay, and so your homework partially would be to finish up these problems that I've given you here. All right, now, if you go to our class website, okay, if you go to our class website here, right here, and you go down here under the web links, way down here on the bottom left, there's 2 antiderivative ones. Right here it says derivative and antiderivative practice number 3. It was derivative practice number 3. It's got antiderivatives. That's probably the best one. And then there's one down here. Let me do this one down here that says antiderivative practice. When you go to that, there's a bunch of stuff in here. There's not much that's real good here. It does say you can review and practice integration by parts here. So when you go there, okay, that gives you just a few. The problem is we don't have a lot of integration by parts practice ones, but we did most of the decent ones in chapter 8. Here's a few that are pretty good though. I would say until you get to this one, number 5 is when you have to do it twice. This one is where it repeats over and over, and so I would not do that one at all. So I wouldn't do this one at all. This one you have to do twice, and then these 4 would be just some practice doing integration by parts on those. So that's not, but that's probably the best. That would be one link I would click. Most of these links I wouldn't go to. A lot of them aren't even active anymore. The other one, it says you can find lots of practice for substitution here. And so the integration by parts link right here isn't bad. And then the one down here where it says lots of practice for substitution. And you come here, it says click here to start the quiz. And it gives you kind of some use substitution ones where you could maybe do that. And you can check your answer. It's kind of multiple choice. I don't know how good multiple choice is because you can kind of see the answer. But whatever, it's up to you. That would be an option. So, but that website's probably my least favorite, but there's a couple places you can go. This one is from this university here, and I think I've given you this one for the derivative tests, the same site. These are the derivative tests over here. These are the antiderivative tests over here. Now, each one of these looks pretty similar. It gives you, I think it's like 8 questions. Now, the thing you got to realize here is they're all kind of in the same order, each of the tests. This one's typically just a basic antiderivative, be a good one to do. This one is typically a U substitution with a definite integral. This one is usually a U substitution or just kind of a basic one. 4 is always going to be one we can't do. 4 is a technique we haven't learned. So 4 you would always just want to skip. So my fear is you come in here and you're trying to do number 4 and you're like, oh my God, what's happened? 4 you'll never be able to do on any of these here. This one, 5 on this one, sometimes is okay. This one is pretty much a basic antiderivative again, it looks like. 8 is always an integration by parts. It'd be nice on the gateway test if you always knew which one was going to be an integration by parts. But 6. 6 is always an integration by parts. This one is typically, again, another U substitution. 8 sometimes is one we can't do, and then sometimes it kind of is. So you got to kind of know that going in. So you might be a little careful with 8. But 4 for sure is one we can't do. The rest of them usually are, and there is an integration by parts. And then you do have the solutions. So when you go to the solutions, like here, if I go to the solution and I look at number 4 and I see this A over B, it's called trig, or it's called partial fractions. It's called the method of partial fractions. And you see this A and B, hopefully you would look at that and say, oh my God, that's clearly not something you've ever done. So I can't do that. Okay. So there are some U substitutions here. You see their integration by parts over here. They use W, it looks like, more than U under substitution. But anyway, so that's not a bad one because it's got them worked out. It's got these different practices. It's got them worked out. So that's not a bad place to go. They're not overly difficult, but that's okay because, before you can get 8 out of 10, you got to get the easy ones, right, or the medium ones. You got to be able to do kind of those basic ones. So that's pretty good practice on those right there. So I would encourage you to visit that site to get some problems. But also for U substitution, we got that page like 23 through 74, right, section 5.4 in the book. A whole bunch of them in there that are U substitution ones you can do. I think I got that right, don't I? Page 341. Page 341 down, even up through number 74 there. Those are some good ones. Those are mostly U substitution ones. But if you want some integration by parts ones, you can make them up like a mixture of function families, or you can go to these websites and you can do something. Okay? All right, so finish up those 11 that I gave you today. Go to the websites, go into the book. The LH packet, there's some more. If you go to your assignment sheet here, okay, if you go to that, your Chapter 5 assignment sheet, there are just some random ones here written out in the LH packet. Those are good ones to do, okay. So any of the LH packets on this sheet that you haven't done yet are good ones to pick up and do, all right. And of course, this is the LH book, so answer book. So, all right. One more day to practice, and we'll do the quiz on Thursday.